Hi there. So, as I've said in some of the previous videos, my name is Ian Candy. I'm Professor of Physical Geography at Department of Geography, Royal Holloway, and I'll be teaching you your physical geography lectures over the course of the first term. And we'll deal with a range of ideas. We'll deal with climate, we'll deal with weather, we'll deal with things like glaciers, flooding, rivers, deserts, coastal processes, all of those kind of things between the start of term and Christmas. The first thing we'd start talking about, though, is climate and weather. How the climate system works, how the climates of different regions of the world vary and why, but we also deal with climate change and some of the impacts of climate change. So all I'm just going to do with this very short video is just run through just some of the concepts that you might want to think about before starting, and just some of the things that we do in the department, that we research, how this feeds in, but just some concepts really to get you to think about climate change in preparation for the start of the year. And I've entitled this Climates and Climate Change Past, Present and Future because we deal with climates of the past, what's happening at the moment, and what might happen in the future when physical geographers talk about climate change. The climate of the past is really important because climates change naturally. You know, climate change is natural. There's no period of time, hundreds of thousands of years where climate is stable. Climate is always dynamic, it's always fluctuating. What physical geographers often do is study climate change in the past, understand what drives that climate change, and then look at what's happening at the present day and over the last 100, 200 years, and actually explain why that's different, why what's happening now requires human impact and is different from what's happened in the past. We also deal with what climate change means for the present. How is climate change affecting our lives now? How is it affecting societies around the world in different ways? And then, of course, it's thinking about what might happen in the future and what the impacts are for societies around the world. And really, this short presentation just covers those three main points: climates of the past, climate change at the present day, and what might happen in the future. Well, one of the most iconic images of climate change is the hockey stick curve, which is shown here, produced by Michael Mann and a range of other scientists, really just to understand how climates vary over the last 1,000 years and how that might be different from what's going on in the 20th century. Now, the crucial thing about this curve and why this record was created was because to really understand how humans have impacted on climate, we need quantified high-resolution temperature records going beyond the period in which humans affected climate. So the Industrial Revolution, 1750, quite often used as a point at which when humans start to burn fossil fuels, we start to change climate. But most of our instrumental weather station data don't go anywhere near 1750. They go back 100, 150 years. They don't go beyond that start point of human influence. So what Mann and his co-workers tried to do was to take temperature reconstructions based on tree rings, on ice cores and corals to produce a quantified temperature record going back thousands of years. Okay, in this case, 1,000 years. They've also published records going back 2,000 years. And effectively, it's trying to contrast what's happening in the 20th century in terms of warming with what's happened over the past 1,000 years. And really, this image summarizes the importance of understanding the past because it shows that climate does vary. You know, you look at that 1,000-year period, there's periods of colder climate, there are periods of warmer climates, but none of them are anything like the warming which has gone on the 20th century. And just to explain sort of the details of the graph, the y-axis, 0 represents average temperature between 1960 and 1990, which is often the point at which climate scientists use as a base level. When the line is below that, it's colder than that 1961 to 1990 average by half a degree, by a full degree. And when the line is above that 0 line, it means it's warmer than that period. And what you can see is that most of the last 1,000 years is cooler than that 1960-1990 period, and temperatures vary quite a bit. But this rapid increase, this trend towards much warmer temperatures, which starts around 1900, is unique within the last 1,000 years, and really highlights the difference between the warming which has happened over the past 1,000 years compared to the 20th century. The red line is instrumental temperature reconstruction, so that's using weather station thermometer data. The blue line is inferred calculated temperature from icicles, tree rings, and corals. And one of the points that Mann and co-workers have always highlighted to sort of support their view of that this is valid is that where the two overlap, they agree quite nicely. So understanding the past is really fundamental in putting current warming trends into context and showing that they're different. Now, it might be that you're looking at climate over the past 1,000 years. Many geographers do that, but we might have to go further into the past. So this artist reconstruction, you've got elephants, you've got hyenas, you've got hippos, you've got rhinos. Well, that's South Wales, but that's South Wales 125,000 years ago. And Britain's climate 125,000 years ago was warmer than the present day, possibly by a degree or so, possibly by a bit more. And it's a period known as an interglacial, a period of warmth between two ice ages. And this warm period was characterized by this African-like fauna. And of course, understanding periods in the past like this, periods of warmer condition, enhanced warmth, are really important. Now, greenhouse gas concentrations weren't particularly high during this period, but the warmth that you got here was because the shape of the Earth's orbit, the tilt of the Earth's axis, was different to the present day, and that enhanced warmth, particularly in the summer, and that was amplified through the Earth system and produces warmer conditions. One of the reasons why we study climates in the past is during this period of time, parts of the Greenland ice sheet, parts of the Antarctic ice sheet probably melted. Sea level was perhaps 5 meters higher than the present day. So periods like this, when naturally the climate was warmer, or as warm as the present day, and processes like the melting of Greenland and Antarctica, which are predicted for the future, actually occurred, allow us to study what our future might be like, but in the past. But a lot of physical geography also deals with climate at the present day. And I've got two images here of flooding related to storms. The one on the right is Louisiana, just after Hurricane Katrina. Hurricane Katrina hit the United States in 2005. And many people are arguing that one of the impacts of global warming is that hurricanes in the North Atlantic may become more common, or they may become more strong or stronger. They might become higher magnitude events. And so flooding and loss of life that we saw in Hurricane Katrina in 2005 might be more common. But it's not just hurricanes, although hurricanes are widely discussed. The photo bottom left is, well, that's actually just down the road from Royal Holloway. That is the main road in the background there is the M25, and effectively somewhere in the middle of that lake is the River Thames. In the winter of 2013-2014, southern central Britain was hit by record rainfall, and that caused systems like the Thames to burst its bank, flooding large areas of residential housing, causing lots of damages to business and also to people's homes. And lots of people argue that these flooding conditions, these wetter conditions which produce flooding, are also a result of global warming. Our winters become warmer, warm air carries more moisture than cold air, and so our winters become wetter and flooding appears to be more common. But actually understanding these trends are quite difficult. How do we know that you're not just dealing with one exceptional event rather than a long-term trend? So understanding what's going on at the climate now, and whether that's just freak years or whether that's a trend towards more extreme conditions. Again, that's something that we think about when we're dealing with climate change through the spectrum of physical geography. And then, of course, we think about the future, because if you know that what's happening now is due to humans, and if you can see the impact of that at the present day, the next step is to try and predict what might happen in the future. This is quite an old figure now. This is 2007, so it's about 13 years old. But just to give you an idea about what climate scientists are predicting what might happen for Europe in the future. And we'll talk about Europe in the future in one of our first few lectures of the first year physical geography course, thinking about what Europe's climate is like now and what it might be in 50 to 100 years. Well, the top row of maps there, the ones which show temperature response, effectively what they're showing is difference in temperature, far left is annual, DGF means December, January, February, so that's winter. JJA is June, July, August, so that's summer. And effectively, what you're showing there is difference in temperature at 2100 relative to 2000. And the stronger the red, the warmer the area is getting. Effectively, if it's getting colder, it's in blue. And as you can see from those maps, all of those maps are orange to red. All of Europe will become warmer in the future. Some areas will be hotter than others or experience more warming than others. And the bottom row of graphs there is rainfall change in the future. This is percentage difference in rainfall between 2000 and 2100. And a much more complicated picture there because the brown areas are drier than the present day. The green areas are wetter than the present day. And you can see this really strong contrast between Southern Europe, which will become a lot drier, and Northern Europe, which will become a lot wetter. So we'll start thinking about what people are predicting about Europe in the future, and then what that might mean to other parts of the Earth system. And this is from the same climate report, 2007. Really, once you start getting those predictions about temperature and precipitation change, you can start to model what might happen to things like glaciers and sea level, because as the world warms, the water in the ocean expands, so sea level rises, and as the Earth warms, glaciers melt, water is returned to the oceans, and sea level rise. And this is a nice graph to finish on, really, because what it's showing is past, present, future. The period in grey is estimated sea level change in the past in millimeters. The red is monitored, recorded, studied sea level change over the last 100, 125 years. And the blue line, the blue shaded area, is projections for the future. And we'll be thinking about what does climate change mean for things like sea level, for things like flooding, as we go 50 years, 100 years into the future. So on this applicant website, I've uploaded some links basically to some YouTube videos, basically with other scientists talking about climate change in relatively straightforward manner. So they should be really interesting and really accessible. The other thing I've put is a link to a paper which was produced by the Royal Society of London, but also the National Academy of Sciences in America. And it's a really, really nice article to start getting you think about climate change. It's basically 20 most common questions asked about climate change, and then a response from the scientific community to that question. And I quite often get my first years to read it because it deals with past, present, and future. And it deals with many of the questions that people have about climate change, answered in a very straightforward and easy to understand manner. Now, there's no need for you to do any reading or any preparatory work before you start your degree at Royal Holloway. But if you're interested, if you want to get back into the swing of learning, if you want to engage with some geographical concepts, those are great places to start. And right at the end of the document that I've posted with all the links to YouTube videos, I've just put 3-4 questions, which are questions you should be able to start to think about answering once you've seen the videos and once you've read the article. Like I say, this isn't homework, it's not preparation for first year, but you don't have to do this. But if you feel like you want to start engaging with some geographical ideas again, that's a good place to start. And the nice resource that I've put up, Climate Change Evidence and Causes, jointly produced between the Royal Society and the National Academy of Sciences. Really, really nice introduction to ideas relating to climate change, past, present, and future. Please email me if you've got any questions about anything I've been talking about on any of these videos. And I'm looking forward to seeing you all in September.